All right, in this section, we are, again, looking for limits. But we're doing algebraically. We're doing that algebraically. Remember last time I said that in math, there are always three ways to solve any problem. And that's graphically, numerically, and algebraically or analytically. Well, we did graphically and numerically in section 1. Today we're doing it algebraically or analytically. Okay, so here are some properties of limits. What you need to know firsthand is that limits, they follow most of the rules that you've seen in algebra. So one is the sum property. It says if you have to find the limit of two terms, okay, then that's the same as finding the limit of the first term, then finding the limit of the second term, and adding them. So for example, if you had to find the limit as x approaches 4 of x plus 3x, okay, then you can separate these, divide and conquer basically. You can find the limit of x first, and then you can find the limit of 3x, and then you add them. So it's just divide and conquer. That's all it says. And guess what? The difference property is the same. If you want to find the limit of f of x minus g of x, something minus something, you can find the limit of the first, find the limit of the second, and subtract. Okay? If you've got a scalar, remember, is just any number, you can take that out. So for example, if you had to find the limit as x approaches 4 of 3x, whatever is a number, if it gets in the way, you can just take it out and you can say, okay, let me just get rid of the 3 and then just find the limit of the variable and then you multiply them. Okay? Now let me tell you something. Well, let me go through these first. The product property is the exact same as the sum and difference. If you want to find the limit of something times something, you can find the limit of the first, the limit of the second separately, and then multiply them. Same with the quotient. You can find the limit of the first thing separately, the limit of the second thing separately, divide them. And then we've got the power and the nth root property, which we'll go over in examples. Now, let me tell you something. We don't really memorize these. These aren't things that you memorize like you would, like the properties of logs, okay? You just inherently use them, but if somebody ever comes up and questions why you're doing something the way you're doing it, you can just say, you know what, this is my backup because the properties tell me to do so, and because Ms. Malikian said I could do it this way, all right? So let's go on to this one, and we're going to apply the first and the first, second, and even the third one in here, okay? So we're going to evaluate the limit as x approaches 4 of this polynomial. Remember, what you can do is you can divide and conquer this. So you can first take the 6x squared, then the minus 6x, then the negative 3, then the positive 3. So here's what I do. First, I find the limit as x approaches 4 of 6x squared minus the limit as x approaches 4 of 6x. Why minus? Because there is a minus in front of the 6x. Plus the limit as x approaches 4 of 3. Now what I can do is I take the constants out. So here this is 6 times the limit of x squared as x approaches 4 minus 6 times the limit as x approaches 4 of x plus the limit as x approaches 4 of 3. Now, When you've got a constant, okay, only a constant, so the limit of a constant, a number, okay, the answer is just that number. So that's just 3. Okay? For any other case, what you do is you take this number and you plug it into here. Okay? So in this case, this is going to be 6 times 4 squared, which is what? Well, 6 times 4 squared. And then we have minus 6 times what? 4. Okay? Because you plug the 4 in here. So finally, when you do all that math, what do we get? 6 times 16 minus 24 plus 3. How much is all of that? 75. So that's the limit of that function as x approaches 4. Okay? Okay. Now look, this is going to be a lifesaver. If p of x is a polynomial and c is a real number, then the limit of p as x approaches c is just p of c. What does that mean? Plug in c. Okay? And if it's a rational function, then you do p of c over q of c. You just plug in c. Okay? So from now on, rather than doing it this way, which can become a little tedious, all we're going to do is take this number and plug it in. Okay? Yeah. To find this one, for example, it's the limit as x approaches 2 of this. We're going to take 2 and plug it in here. So this is going to be 2 minus 3 over 2 times 2 squared minus 2 minus 15. Do I need to see the work on the test? Yes, I do. Because that's how you differentiate between this and plugging it into your calculator and graphing it. So on top, I get negative 1. And on the bottom, I get 2 times 4. That's 8. Minus 2 is 6. Minus 15 is what? Negative 9. So the limit here is 1 over 9. That's all. Okay? All right. So look at this one. It's x approaches minus 1. I take minus 1 and I plug it in there. So I get the square root of negative 1 plus 3. This is the square root of 2. And as long as it's a simplified radical, then we're good. Okay? Okay, one more. Here, x is approaching 4, so we plug it in there. 4 cubed minus 3 times 4 squared minus 5 times 4 plus 7. What does that equal? 4 cubed, 64, minus 3 times 16, minus 20, plus 7. And how much do we get there? You have an answer? 3. Okay, one more. We plug this in. What do we plug in? Negative 5 plus 1 on top. On the bottom, I get negative 5 in parentheses squared plus 3. Negative 4 over what? 28. So that's negative 1 over 7. Okay. Look at this last one. X approaching negative 8, okay, and we're looking at the square root of x plus 6. Well, what happens if you just blindly plug it in? You get the square root of negative 8 plus 6, which is the square root of negative 2. And what is that? Yeah, but we don't do i's. We just deal with real numbers here. So this is DNE. And really, if you take a look at this, we know what a square root graph looks like, right? It looks like this. However, this is the square root of x plus 6. So what does the 6 do to the graph? Where does it move it? To the left 6. So this starts at negative 6. Now, we're looking at x approaching negative 8. There isn't even a graph there. Like, it's just desert land, okay? So it's definitely DNE, all right? Now, this is fine, but it's kind of boring, right? Because, okay, you just plug in a number and you get, we've been doing this in pre-algebra. So what is it that we're doing here? Well, when does it get interesting? It gets interesting when you can't get an answer, okay? And we call that indeterminate form. What do you think the word indeterminate means? Cannot be determined, meaning you can't really gather any information based on what you have, okay? So when direct substitution, which is what we've been doing, results in 0 over 0. Now, this is important. It's when you can get a whole bunch of weird stuff, but it's when you get 0 over 0, okay? We say that it is an indeterminate form because it is impossible to determine the limit, okay, with a denominator of 0. Because, what do you know? It could be anything, right? In such a case, it's necessary to use other methods to determine limits, okay? It is possible. Now, when you do this, there are three cases. It's possible that the limit exists, or it'll diverge. Remember diverging? So you'll either get that the limit exists, or you'll get positive or negative infinity, which means it diverges. All right, so let's repeat. This is when you plug in a number and you get 0 over 0. I'm not talking about any other thing. I'm not talking about 0 over 5. I'm not talking about 5 over 0. I'm talking about 0 over 0. Okay? That's indeterminate, and there are several things you have to try. One of the things that we do is factoring. How do you know which you're supposed to do? Well, it'll be obvious. Okay, so this one, we need to try to factor. So let's see. The first thing that you do is you plug in negative 2. So let's plug in negative 2. Negative 2 cubed minus 3 times negative 2 squared minus 4 times negative 2 plus 12 over negative 2 plus 2. Right? So on top, I get negative 8 minus 3 times 4 is 12 plus 8 plus 12 over 0. So what is this? 0 over 0. Okay? Now, we got 0 over 0. This is indeterminate form. So I have to do it another way. Now. Huh? No. Okay. When you're going to work with a limit algebraically, this comes along at each step. In fact, if you happen to forget that in your work, even if you end up with the correct answer, points will be taken off. Okay? All right. So we're going to factor this. So this is going to be the limit. As x approaches negative 2, I can't really factor the bottom, so I'll just leave it that way. Okay. We have a cubic polynomial on the top, and it's got 4 terms. What method of factoring do you think we're going to have to use here? Grouping. Awesome. We split it down the middle. This, we can take out an x squared from here, and I get x minus 3. From the right side, I take out a minus 4, and I get x minus 3. How convenient. So this is the limit as x approaches negative 2. Now, remember the common term here is what? X minus 3. So I factor this out. And then I just copy over anything that I've got left. X squared minus 4 over x plus 2. All right, we're almost there. This is the limit as x approaches negative 2. X minus 3, x minus 2, x plus 2. When you least expect it, those factoring concepts are back, right? Here we go. X minus 2. So what happens now? These go away. Okay? Thank goodness. Because what was really giving us the problem? The denominator, right? And we made it go away. All right. So the final answer is this. Now we can plug negative 2 into here. Okay? So plug negative 2 into there, and we get negative 2 minus 3. Negative 2 minus 2. This is what? Negative 5 times negative 4, 20. So that's the answer. All right? Right, only when you're dealing algebraically with the equation, you put the limit. But when it's the number, we never put the limit sign in front of the number. All right? Because once you substitute, you take the limit away. Okay, yeah. Once you've gotten rid of that denominator, right? Once you've neutralized the situation, that's when you put it in. Okay, so here's another one. We're going to plug 6 in. We get 36 minus 42 plus 6. That looks like it's a 0. And here we get 3 times 36 minus 66 minus 42. What do we get in the denominator? Can somebody make sure? 3 times 36 minus 66 minus 42. 0. Okay, 0 over 0 is an indeterminate form. It could go either way. Okay, I can get an answer like I did with this one, or I might just get infinity. Okay, so let's see. Okay, so this is the limit. As x approaches 6, let's factor the top. What do we get? Yes. And the bottom? Yep. I'll just wait. 42. Not too many choices. 6 and 8. Where does the 6 go? 6 and 7. So 3 times 6 is 18. We need to make that positive and that negative and that positive. Okay, so now can we get rid of the x minus 6? We sure can. That means this is the limit as x approaches 6. Let's just write it cleaner of this. Now I can plug in my 6. So I get 6 minus 1 over 3 times 6 plus 7. This is 5 over what? Which is 1/5. All right? Oh boy. So that was factoring. What if you've got one like this? So let's plug in 25 here. 25 minus 25, that's a 0. Okay, the square root of 25, that's a 5 minus 5. Oh my goodness, 0 over 0. Also indeterminate. There is no way I can factor this. I mean, this is not something that factoring even applies to. But I've got roots, and anytime you've got roots, you've got to rationalize. Okay? So how do we do that? Let's copy this over. The limit as x approaches 25. x minus 25 over the square root of x minus 5. Oops. Now, I need to rationalize the term with the root, right? So I have to multiply top and bottom by the conjugate of that root. Now, if this is the square root of x minus 5, then what I need to multiply by is the square root of x plus 5. That is the conjugate. And whatever I do to the bottom, I have to do to the top. Otherwise, I've changed the equation forever, right? Now, the denominator, right, where you've got the root, that's sort of a simpler case. So this is the limit as x approaches 25 of, now, the denominator, what you have is a minus b, a plus b. So you square the first term, you get x, minus, you square the second term, you get 25. Now, the top needs to be FOILed. You have to put parentheses around that first one too, otherwise it'll fool you. All right, so let's FOIL that one. We multiply x in. So, okay, so the first terms give you x root x. Outer terms give you 5x. Inner term gives you negative 25 root x. And the last terms, negative 20. So this is negative 125, sorry, I subtracted. Okay, I don't have enough time. All right, I will stop right here. All right, so I'll take out the rationalization problems. Go to 1 to 27 odd. And you're also going to skip 7. Oh, no. Sorry. You're going to skip 17. Okay? So that will be due tomorrow.